In this video, we are going to be implementing the encoding for the monoalphabetic cipher. For the monoalphabetic cipher, what happens is that each letter of the alphabet is mapped to another letter in the alphabet. There is a one-to-one mapping from one letter to another letter. So in this case here, you can see the mapping from the plain alphabet from A to Z into a cipher alphabet. So the letter A is mapped to Z, the letter H is mapped to D, the letter T is mapped to Q. And at the bottom here, you'll see what it will look like when you encode a plain text using the monoalphabetic cipher. So the string, this is super secret, becomes this rather unreadable ciphertext, and so your layperson who encounters the ciphertext is gonna go like, I have no idea what this is saying, right? So this is, and we talked about how the monoalphabetic cipher is more secure, or rather addresses one of the weaknesses of the scissor cipher, in that the key size of the monoalphabetic cipher is huge. You know, there's 4 times 10 to the power of 26 possible keys mappings. You know, from the blue to the red row, there are 4 times 10 to the power of 26 possible combinations. And the time taken to explore every single key in this key space will take a computer, you know, way too much time, millions of years, and that's the concept of why we will want to use the monoalphabetic cipher. Later on, we'll discover that it is susceptible to attacks, specifically frequency analysis. But for now, we are going to focus on how to code up the encryption of a plain text using the monoalphabetic cipher system. Okay, right. So we have our plain text. To simplify things, I'm just going to use lowercase for everything. The quick brown fox jumps over the lazy dog. We'll use this sentence here as our plain text. And we will also need to have a mapping, right? And so the mapping, the key would be the letters of the alphabet from A to Z, all jumbled up, right? Each letter can only appear one time. And one of the easiest way, or rather one of the ways that we can kind of simplify the mapping, is to choose a word or choose a phrase as our key, right? And then we'll type out the phrase. So let's say our key is zebra is striped, right? And so what then you need to do is you need to remove any letters that are repeated. Okay, so now all these letters are all the repeated letters have been removed, and then we will then fill up the rest of the key with you know, the rest of the alphabet in order, right? So that's A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z, right? So hopefully these are all 26 letters of the alphabet and that there is no repetition. And I'm just going to do a quick check here. Let me go quickly to the console and let me ask, what is the length of this key? 26, right? Okay, so that's a good heuristic to for us to be certain that that we have represented every letter of the alphabet once and only once. Okay, so we have our key. So why would we do this things this way? Is so that in order to transmit a secret to a friend, to the intended recipient, we don't have to send them this convoluted string, we could give them a sentence, a zebra is striped, and then our intended recipient can do the exact same process that we did to come out with the same key mapping, right? Or the key, you could hint to your friend, look at the first three words on page 17 of Harry Potter and the Philosopher's Stone book, right? So that way you're being indirect in the way in how you are transmitting the key. So your intended recipient will look up the Harry Potter book, turn to the page, take the first three words, and then do the exact same process to come out with the key mapping, right? So it's a much friendlier way to transmit the key using a sentence or phrase rather than to send over this convoluted string. Okay, right. So let's do the encoding. We can draw upon our experience doing the scissor cipher program. We know that we'll need to iterate through every single letter of this plain text. So we'll use the for loop syntax. For variable, I'm going to call my variable, I don't know, for C, right? I'm just going to give it a variable name for C. It's not a good name, actually. It's not very descriptive. So for C in the plain text string, and what happens is that it's going to go through every single letter in the plain text. And I'm just going to, I've done this before, but I just want to show it again. I'm going to print the letter C, and I'm going to run it so you can see what happens. Right, the quick brown fox jumps over the lazy dog. Now we want to then convert the letter into a numerical representation so that we can do operations on it. And we know that these are ASCII letters, which means that they are actually represented by a number. So if I look over here on the right hand side, on the last column, you'll see that the lowercase letters A to Z are represented by the numbers 97 to 122, right? And so we can use the built-in function in Python, the ORD function, okay? And that's going to return, let me run the module, that's going to return the value, the numerical value of the character, right? So T is returned as 116, and if you look at the ASCII table, you look it up, T is indeed 116 on the ASCII table, right? The other thing we want to do is that we want to have start our indexing from 0 rather than from 97. So A shouldn't return me 97, A should return me 0, B should return me 1, C should return me 2, and so on and so forth, right? So what then I will do is that I will minus away your base number, which is stored by the first position, which is A, 97. So let me run this module. Oops. And I made a mistake here. I keep making this mistake. It's not a variable A, it's the character A. So I do need the quotation marks. Okay, so we have this, and most of the numbers are between 0 to 25, which is exactly what we want, except there are this negative 65 that appear, right? And you'll see that it is actually it is actually 32 minus 97, and that's the space character. So we know that we need to exclude any punctuation, any spaces. We only want to deal for characters that are lowercase, right? And so we will import the string module, and we'll go like if C in ASCII dot string dot lowercase, or rather ASCII. Okay, I've forgotten. I can look it up on Google, but I'm just going to import the string module here, and let's take a look at what it has. ASCII lowercase, a string containing all ASCII. Okay, right. So ASCII underscore lowercase. I'm using the built-in help in your console, right? So only if our character is a member of a lowercase ASCII do we do this. Otherwise, we're not going to process it. And so at this point, I'm going to then establish our output string. So I'm going to create a variable called cipher, and that starts off as an empty string, and we're going to build it up as we do the encoding, right? And I can already fill it up here, whereby, right, if our character is not an ASCII lowercase character, I'm just going to append it to the cipher string. Okay, but if it is, right, I'm gonna have to do a bit of processing, right? So that index I'm gonna store inside a variable which I will name index, and you'll notice that that index is exactly the index in the key that we need to extract out, right? So if our character is A, for instance, right, we actually need to know what A maps to, and that's actually the first position in our key because A is the first character in the alphabet. And if our character is B, right, we actually need to look up the second position in the key, right? And we have actually gotten that in this line by finding what is the index of the character in the alphabet, right? So then it's a simple lookup. We'll use the square operator, right? So key index is going to return us at the character in the key string, right, at the index, at the position index, right? And that's what we want to be adding into our cipher. And at the end, let's print our plain text. And let's print our cipher. And I'm gonna misspell cipher just so that it's the same. Oh, well, I could add an extra space here. There you go. Okay, let's run this to see whether it works. It might have bugs in it. You can stare at this for a long time, but it's easier just to run it and to see what happens. In this case, there's no mistake, which is good. We do get encoding of that, and we want to just maybe quickly eyeball it. Z maps to Y, that's correct. T maps to O, let's check. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T. Yeah, that's right. T maps to O. Right, so this seems to work. And so this will be the encoding for the monoalphabetic cipher. And actually, it's a bit simpler than our Caesar program. But the key here is knowing how to use the index of operator, those square brackets, right, to retrieve a character from a specific position in the string.